Hello everybody, good morning. So, we discuss failure and repair intensities today. In last class, you have seen that we introduced some new parameters for combined process, which is basically the repairable unit. In a repairable unit or for repairable system, you know the basic characteristics are: once the component fails or the system fails, it will be repaired and then it will go to its normal state, means it is in the working condition, and again under use after certain time it may fail, then it undergoes through the repair process, and that failure process and repair process two are combined, and we said that that is the combined process. And apart from reliability, apart from failure distribution, apart from failure density, from failure rate, we introduced availability, we introduced unavailability, we have introduced different failure intensities like conditional failure intensities, unconditional failure intensities, similarly conditional repair intensities and unconditional repair intensities. In today's class, we will discuss the theoretical basis of failure and repair intensities. So, we are relying on the same book written by Komamoto and Hinley on probabilistic risk assessment and management for engineer and scientist, and most of the material taken from this book. So, if you recall, in last class we started with an example and then we have discussed different parameters, and those parameters are listed here. For example, availability, for example, unavailability, for example, conditional intensities, for example, unconditional intensities, for example, expected number of failures. And then we have defined all those things, and finally, we have shown you how to compute the availability, unavailability and the different intensities, but we could not explain in details from the example given to you. So, today what I thought of that, let me start with that example and then I will come to the theoretical basis of that computation of failure intensities given Ft and Gt, where are the failure densities. So, what is the objective of today's presentation? Given failure density, that is Ft, and repair density, that is Gt. So, we want to compute unconditional failure and repair intensities Wt and Vt, as well as conditional failure and repair intensities lambda t and mu t. Okay. So, we start with the example and we will explain these things so that you can relate with the previous lecture. I hope that you are going through the book as well as the video lectures regularly. So, then if there is any disconnect, you are revisiting or reviewing the video again and then you are getting it understood. Okay. So, let us go to this example. I request all of you to listen carefully. If you listen carefully, definitely you will understand every bit of the sentences, the words we are using, the figures we are showing, and the computation steps we are deliberating. So, this is the example given in the last class. I will not spend much time here. We have shown to you that there are 10 identical components and it has its failure repair process, and accordingly what happened, we found that that there is some component which has gone through failure repair failure, some component gone through failure and repair, some component gone through normal state and then failed, but repair process is not completed. So, as a result what happened, the meaning of availability comes handy, and you know what is the availability, that the probability that component is available or normal at time t, given that it was as good as new at time t equal to 0. So, with this example, let us try to compute what is the availability at time t equal to 7. So, that means you are here. So, now you see that how many components under test, 10 components. So, the denominator is 10. So, how many components are normal or working at t equal to 7, that point on time? You will find out that component 10 is working, component 8 is working, component 7 is working, and rest of the components are under failed state. So, there have been 3 components working at t equal to 7 unit, given that at time t equal to 0 there are 10 units working. Okay. So, that is why the availability is 0.3, 3 by 10. So, as you know that availability plus unavailability will be 1. So, availability is 0.3, so then your unavailability will be 1 minus 0.3, that is unavailability will be 0.7. Or other way you can find out that how many at time t equal to 7, how many component are under failed state. Out of 10 component, 3 are at working state, so 7 are at failed state. So, that is why Qt equal to 7 by 10, which is 0.7. So, then there is another issue that is unconditional failure intensity. Unconditional failure intensity basically talks about a situation where we do not bother about what is happening at time t, equal to t, whether the component are normal or not normal. We will bother only at time t equal to 0. So, now what is the unconditional failure intensity is at t equal to 7. So, you have to find out that what in between 7 and 8 how many component fails. So, you see that in between 7 and 8 only one component fail, and although at 7 there are many failure, but in between 7 and 8 this unit of time only one fail, and at time t equal to 0 there have been 10 components working. So, unconditional failure intensity is there, therefore, the number of component fails in between 7 and 8 units of time divided by the total unit of total number of components at time t equal to 0. So, that is 0.1. Another one is the expected number of failures. So, we are considering here expected number of failures from 0 to 7, then you find out that from 0 to 1 to 0, 1 to 2, 2 to 3, like this up to 7. Okay. So, from 0 to 7 this one. So, you will find out that how many 1, 2, 3, 4, 5, because from 0 to 1 there is no failure. So, as a result ultimately, and from 1 to 2 there is one failure, from 2 to 3 there is again one failure, 2 to 3 this failed, and 3 to 4 this is normal, this one failed. So, there again one failure like this. So, 1 by 10 all is summed up and you got that expected number of failure is 0.7. And then comes the conditional part. Conditional part means it is a different population. When we are talking about unconditional failure intensities, we start with 10 components here with this example. So, 10 number of population, the population size is 10 and we found out that in between 7 and 8 how many fails, that is fails 1. So, that is why the unconditional failure intensity is 1 by 10 equal to 0.1. But in case of conditional part, we are adding another condition that the component is normal at time t equal to 7. So, at time t equal to 7, how many components are working condition or at normal state, that is 3 only. So, then within 7 and 8 how many fails, 1. So, that is why the probability of conditional failure intensity is 1 by 3. Okay, probability that component will fail per unit time given that they were as good as new at time t equal to 0 and normal at time t equal to t. I hope that you will be able to compute by your own. Okay. So, now we will see the theoretical basis of these unconditional failure probabilities or unconditional failure intensities and unconditional conditional failure intensities, unconditional repair intensities and conditional repair intensities. So, first we start with unconditional failure intensities. So, we are interested to know for what? We are interested to know what is WT, unconditional failure intensity. So, if you think that your time interval is t and t plus delta t, so we want to know that what is the unconditional failure intensity, the probability that the component will fail per unit time at t given that the component is as good as new at time t equal to 0 and normal at time t. So, component, that is what is basically unconditional failure intensity. So, the two type situations will occur. One is that component is normal at time t and it has been normal from time 0, that is this second one. Another one is that component fails in between, maybe between, and let it is repaired in between u and u plus du and then again failed in between t and t plus delta t. So, as a result what happened, we have two types of situations, two outcomes, and we are saying that two types of component also we can tell. So, issue is that in the first type of component, so as it fails in between this one time and it is basically then repaired in between u and u plus del u. So, that is one condition. So, we are writing repaired during u and u plus du and then it is normal up to time t and after that it is normal to time t and then again fail in between t and t plus delta t. Okay. So, as a result what is happening, what is the probability? Probability here there are two issues, one is it is repaired here and then it has been normal up to time t and then again it failed. So, these two will be multiplied here, the probability will be bu du which is basically it is repaired in between this time and again it is basically failed within t and t plus delta t and as it is repaired here already u amount of time is elapsed. So, f t minus u into dt. Then what is our VU du? Probability that the component is repaired during this, given that it was as good as new at time t equal to 0. And then what is f t minus u dt? The probability that the component has been normal to time t, please read this, has been normal to time t and failed during t and t plus delta t, and obviously the other condition is that it was as good as new at time t equal to 0 and repaired at time t equal to u. Okay. So, and in this in the second case what will happen, there is no failure repair issues, it is failing within this t and t plus delta t. So, as a result what happened, the probability here that it fail will be f t into dt. So, this kind of explanation also we have discussed earlier. So, that means we have to consider not only this, also this, because these two outcomes, the two situation can arise. As a result what happened, what will be the our intensity part, unconditional intensity. So, first we are creating this W t into dt. What is W t into dt? This is the probability that the component fell in between t and t plus delta t, given that it was as good as new when t equal to 0. And we found out two situations. One is that it fails from the component 2, that we found out the probability, this probability is f t dt, that it fell in between this. And second one is that it is repaired and then normal from then up to that t, and when it is repaired we assume that it is again as good as new, and as a result that dt times this probability will be used. So, dt 0 to t f t minus u v u du, this v u du coming from the repair side, and f t minus u that it has been normal after repair up to time t. So, that u amount of time already elapsed, but when you repair it is condition is as good as new. So, this delta t and delta t will be cancelled out from this equation, we will find out this equation. This is one of the fundamental equation here. That means what is W t? W t is unconditional failure intensity, which is equal to f t plus integration 0 to t f t minus u v u du. Now, there may be situation, suppose what will happen if it is non-repairable. If non-repairable case, then the second component does not exist. So, accordingly the equation will be W t equal to f t. So, similarly you can go for repair intensities. What is the difference here? You see the component, this is the normal state, normal, then it failed, again repaired at this point, repaired, and then it is under again normal, then again it failed here and it is in the failure state. It is in the failure state and then it is repaired in between t plus this. So, this is repaired between this, and what happened here, it was normal to fail. So, failed in between, failed here in between this. Okay. So, that means this is the failed in between this, we will start from the failure process, and here repaired in between this repaired part. So, two things will be considered, because we are interested to know the repaired intensity only. So, see so that means what is the condition, that failed during u and u plus du, and another one is the has been failed till time t, it is in the failed state up to time t, and then we are interested to know what is the probability that it will be repaired within this t and t plus delta t. So, then this is the one such outcome will be there will be not other. So, that means now this similar situation in the failure intensities case, we said that V u du into f t minus u into f t minus u into dt. Now, here our density changed, it is not failure densities, it will be repair densities in this case, and in this case it will be failure intensities. So, that is why what is the probability that it will be failed in between u and u plus du, failed in between u and u plus du, that is definitely W du, because W is the failure unconditional failure intensity. So, this will be there, and and what is happening after that, it is basically it should be has been normal. So, G tu minus u and dt. So, this is other part from here, it failed that G t minus u into dt, but question is that it has been in the failed state from after that repair, after failure it will be in failed state, and then it will be repaired here. So, that is why the integration is required, it has been in the 0 to t, and when it is failed, completely failed. So, your equation is this. So, unconditional failure repair density is V t, and V t into dt, it basically talks about that the component will be repaired in between, probability that the component will be repaired in between t and t plus delta t, this is the case, and then this equation. Now, this t and this t will be cancelled out, and as a result you will be having this equation. Okay. So, for non-repairable component, what will happen, that W g t 0, W 2 f t equal to f t, that I have already told you, and V t will be 0. If a component failed, component then is repaired instantly, then the combining process will be like this. W t will be f t, 0 to t f t when you do W, and V t will be W t. So, anyhow, so please remember this is little bit complicated definitely from concept point of view, but you require to know all those things, and to me you require to read and as well as listen the video maybe 2-3 times, so that you will get the concepts clear, and these concepts are essential, although for practical people it may be difficult. Practical means the practitioners who are basically working in the field. For you it may be difficult to understand sometimes, but you please understand the message or the physical meaning of all those that parameters, that is very important. And essentially then what we were looking for, that given the we are looking for that given the f t and that is failure density and repair density, then what will be the unconditional failure intensity. This is one formula, and another one is this one. Two important equations. Okay. So, before going to now computing the conditional failure and repair intensity, so you must know that the two important formula we have discussed. One is W t, that we say f t plus integration 0 to t f t minus u v u du. Another one we discussed V t, that we say 0 to t, then this one g t minus u w du. These two formula talking about unconditional failure intensity and unconditional repair intensity. And you see that what you require to know, you require to know this failure density and repair density. Okay. So, now we will discuss another important concept called conditional failure and repair intensity. That definition already given to you. What is the additional condition in case of conditional failure and repair intensity with reference to the unconditional failure and repair intensity is that in case of conditional failure intensity, that the component will be normal at time t equal to 0. Other condition remain same, that are equally valid. Similarly, for repair intensity. Okay. So, now here we will discuss that how the conditional failure intensity will be derived, and similarly analogously you can derive the repair intensity. So, all of you know the conditional probability. If you do not know, please go through conditional probability, and we will not discuss what is conditional probability here. It is the prerequisite for you. So, for the time being you just understand few things. Component is normal at time t, that is one condition. Then component fails during this is what is our subject of interest. Then the component was as good as new at time t equal to 0, that is also another condition. Okay. Now, then if we want to know what is the joint occurrence of A and C, what is joint occurrence of A and C? A means that component, suppose if I go along timeline t equal to t, the component is normal. So, component is normal at time t equal to t, it is normal. And then another one, what is this? The component fails during t and t plus delta t, and this is my t plus dt. So, what will happen? It will basically from normal to it will go to abnormal state, means it will fail. So, the joint occurrence, that means it is the component is normal till time t and then it fails, but in both the cases the condition is w, that means it is as good as new at time t equal to 0. So, then that joint probability can be written like this: probability A C given w. So, this can be, if you know the probability, that conditional probability, that can be written like this. What is this? That probability that the first is the component is normal at time t, given that it was as good as new at time t equal to 0. This is given by this probability C given w. And second one is that the component fails given two conditions. One, it is normal at time t equal to 0 and as good as new at time t equal to 0, and it is normal at time t equal to t. So, that C is talking about component is normal at time t equal to t, w talking about component is as good as new at time equal to 0, and A denotes that component will fail in between t and delta t. So, this probability, joint probability, is the multiplication of these two probabilities. Okay. But here one interesting thing is there. The interesting thing is that we basically choose the interval in such a small value that only one failure can happen, or one event can happen. That is a failure event here, because it is in the normal state, it can go to that abnormal or failed state. So, one failure event can takes place within this small amount of time. So, then if I consider the conditions, then what will happen ultimately? This A and C. What is A and C? That A means it will fail, C is it is normal. So, as within this small time only one one event can occur that it can fail. So, ultimately that A this portion will be reduced to this, that probability A C given W is nothing but probability A given W. So, why? Because if I say probability A mean it fails within this and it is a small interval, only one failure event can occur. So, that means it was normal at time t. So, that means the event A that implies event C also, the condition C. So, this one can be written like this and this portion as it is. Now, with this, now relate to the definitions what we have already discussed. What is WT? What is WT dt? This is the probability that the component fail in between this. Then what is probability A given W? Nothing but this. So, you are writing like this. Now, what is probability of A given CW? This is conditional because C condition is imposed. So, this is not unconditional failure intensity, this is conditional failure intensity, that is A given C. Once you multiply by dt, that you will get the probability. So, that means this relates to lambda t into dt. And the first one what? Component is normal at time equal to t, given that it was as good as nu at time equal to 0, this is nothing but the availability. So, availability is included here. So, that means this relation talks about relation amongst the first part, this part and this part, and if you put all those things into this equation, what you will get? You will get this equation. The reason is that mean probability A given W is probability A given W is WT dt, then probability C given W is AT, and probability A given CW is lambda t into dt. So, this dt will be cancelled out. So, that means WT equal to lambda t into AT. And as you know that availability is 1 minus unavailability. So, you can write like this, and from this equation also, from this equation you can write lambda t equal to unconditional failure intensity divided by availability. Okay. So, now you understand that if you know the failure density and repair density, you can calculate the unconditional failure intensity, unconditional repair intensity, and once you know the unconditional failure, repair intensity and availability other parameters, using the conditional fail probability theorem, you can find out the conditional failure intensity and conditional repair intensity. We have discussed about conditional failure intensity only here using this probability conditional probability theorem. What you require to do, you also require to derive this part. Okay. So, these are the references, and I hope that you have understood it, and we will see some more mathematical issues also in next class, but please remember that this week is more of mathematics, and then maybe in subsequent week again we will go for more of concepts and practice kind of things or application type of things. So, thank you very much.